So remember that myosin likes actin, right? We said that myosin was the boy that wants to dance with the girl at the dance, right? Well, this is what happens once calcium binds to troponin. Okay, so here it is. Calcium is bound to troponin, and that's going to pull tropomyosin out of the way. So now our myosin heads can bind to actin. Cool. Well, once the myosin heads, this is step one of what we call the. Is it going to go back? Is it going to go back? I just want to show you in the cross bridge cycle. Okay, so this is your myosin head. Okay, fitting with those little actin subunits. So myosin binds to actin. As long as calcium's there, myosin can bind to actin. Step number 2, we're going to look down here, the power stroke. And that's how I want you guys to think it and say it. Okay? Myosin, here's myosin, my right fist. My left hand is actin. Myosin binds, and then power stroke. And what happens is it pulls actin along. Okay? So, and just like that's a fraction of a nanometer probably, right? Well, no, it'd be bigger than a nanometer, okay? But fraction of a centimeter. Okay, so after the power stroke, that's when the muscle's actually shortened, okay? What happens is this cross bridge has to break, okay? So, and I'll explain why in a second, but myosin binds and pulls, and actin moves along, right? Well, now what has to happen is we have to break this cross bridge. And the reason we're going to break it is so that we can do this all over again. Okay? This is good. I got a little message here. Chat. Oh, hi, Madeline. Is that Maddie Kless? Okay, hi, Maddie. So it's good to hear from her too. So myosin binds to actin, pulls it. Now we have to detach it. And this is where your muscles actually use ATP, right? What's weird about this is calcium is the trigger that needs to be there for myosin to pull on actin, not ATP, right? And we'll talk about what ATP does. But ATP, when it binds, it breaks the cross bridge, okay? When we break that cross bridge, the next thing that's going to happen is, and I know it's kind of on sloppy lines here, but ATP hydrolysis. We're going to break apart ATP, and when ATP gets broken apart, energy gets released, okay? So as we look at step 4 here, this myosin head gets cocked, right? So myosin kind of, if I just use this example again, we're here, we broke, or we power stroked, break the cross bridge, okay? And now we're going to elevate myosin again. So we're going to energize that myosin molecule. So that's where ATP is going to be used in energizing it. Now myosin can bind and power stroke. What happens is this happens hundreds of thousands of times over millions and millions of myosin little subunits and actin subunits. Okay, so what we get is power stroke, right? Power stroke. And actin is, if I could just start here, right? Break, okay, elevate, bind, power stroke. Break, elevate, bind, power stroke. And it's kind of like, rowing the boat to get our muscle to be shorter. Okay, and I have each one drawn kind of here. Cool, we do this over and over and over again, except my images are sloppy right now. Okay, so what I want to ask you then is, can you give me a preview then into rigor mortis? Okay, why do we say you can pull it out of my cold, dead, stiff hands? And if I were to pull that thing out of his hands, I'd have to fight these fingers. Do you see why now, after looking at that, you picked up? I mean, I'd be impressed. Anyone got it? Why rigor mortis? Rigor meaning hard, mortis meaning dead. Why is your body stiffen up? I'll give you the answer. Okay. What's that?
Muscles are contracted. When the person dies, their muscles are already contracted, so it just stays there.
Yeah, you're on your way. She's right. So what happens is it's not quite that your muscles are contracted. It's that, let's go back to share screen. Okay. Your sarcoplasmic reticulum starts to break down. And do you remember what the sarcoplasmic reticulum does? Sorry, I'm trying to find my... Do you guys hear the kids crying in the background? There's always tears. Do you hear him?
I don't.
Oh, he's screaming. He wants his mom, and mom has to do work with Annabelle. Anyways, as I look through for a picture of sarcoplasmic reticulum, what happens is that stores calcium. and that thing breaks down. Here's a picture. Okay. When the sarcoplasmic reticulum breaks down, once you're dead, calcium fills your muscle cells. Okay. Well, your muscle cells, when they get filled with calcium, calcium's still going to bind at your troponin, which is still intact even though you're dead. Okay. So calcium binds to troponin, it moves tropomyosin out of the way. Myosin then can bind with actin and form that cross bridge and even pull on it. But it's at that point where the cross bridge is ceased, where myosin is bound to actin and actin can't unbind. Okay. And so for a while, the body's kind of stiff and kind of cold and hard. Okay. Can you go to parts of the sarcomere? Yeah, sure, can do. Actually, this is a nice little slide to be on. So I'm going to minimize this. Okay, so I'm going to present right here. So I don't know if you guys can see me or not as I make my hand motions. What's going on here? Sorry, I can't see your chat. Can someone read that chat to me that you just said? So right here is a picture of what we call the triad. And where this is coming next. This is next week. All this stuff going on. Okay, but here's the deal. Here's your sarcoplasmic reticulum. Okay, what it's got is this little thing called, this terminal means end and cisterna means sac. Okay, when action potential comes down the T-tubule, those things are back. Okay, it's going to stimulate calcium to be released from the sarcoplasmic reticulum. Okay, so calcium is released. It's that calcium that can bind to troponin. Now myosin can bind to actin. Okay. So that really, like, the parts we care about are the main part of the sarcoplasmic reticulum that stores the calcium, and then this other part that has a terminal cisternae. Oh well, I guess they all release it, but this is gonna be super close to this area where the action potential is gonna happen across our muscle cell. That's a preview, and we haven't talked about that yet this week. Okay, guys, we got chat. I can't find some of them. Sarcomere. I just looked at sarcoplasmic reticulum. Oh, sorry, little buddy. Yeah, let me do that for you. So let me pull that up. I gotta share my screen again.
Also,